Unit 2A, Lesson 3. In this lesson, we're going to focus on graphing linear inequalities. This process is going to be very similar to graphing linear equations. There's just a few differences. So here's the main idea on how we're going to graph linear inequalities. We're going to use the y-intercept and the slope, or a table of values, to plot some points on the coordinate plane, just like we did with linear equations. The first main difference for graphing linear inequalities is we have to determine whether the line should be solid or dotted, and we determine that by looking at the inequality symbol. If the inequality symbol has an equal to sign, then it's going to be a solid line. If it is strictly greater than or strictly less than, there's no equal to sign, then our line is going to be dotted. Okay, that means the solutions on the line itself, or the points on the line itself, are not solutions to the inequality. Then the last difference is we're going to use a test point to determine which side of our line we constructed we're going to shade. Okay, so when graphing linear inequalities, we have a shaded region that represents all of the ordered pairs that satisfy that inequality. So we use a test point to determine which side we're going to shade. We want to use the origin if we can. It just makes the simplifying process much quicker. Now to the first example, we're going to graph the linear inequality going through those steps I just talked about. So we have the inequality y is less than negative 1/3 x plus 5. So the first step to graphing this linear inequality is to use the slope and the y-intercept to plot some points. You could make a table of values as well if you wanted. So first I'm going to plot the y-intercept of 5. Now I'm going to use my slope, rise over run, down 1/3. So I go down 1/3, down 1/3, which would be the same as up 1 to the left 3 as well. So I plot some points on the coordinate plane. Now I need to determine whether my line is going to be solid or dotted that I construct through these points. So I look at my inequality symbol. It is strictly less than. There's no equal to sign, so my line is going to be dotted. Now that we have the dotted line constructed, we need to use a test point to determine which side of this line we need to shade. So we're either going to shade the region above this line or shade the region below this line that represents all of the ordered pairs that are going to satisfy this inequality. The test point we should pick if we can is the origin, 0, 0. It just makes the process easier when we try to simplify. So I'm going to use 0, 0, plug 0 in for x and y, and see if I get a true statement for my inequality. So I get 0 less than negative 1/3 times 0 is just going to be 0 plus 5. So 0 is less than 5 is what I get. That is a true statement. So if I pick this test point, the origin, and I got a true statement, that means I'm going to shade that region where the test point occurs. If we had gotten a false statement, something that was not true when we plug that ordered pair in, then we would shade the opposite region of where that test point occurs. So we used the origin as our test point, plugged it in, got a true statement. The origin lies below our line, so I had to shade the region that lies below the line we had constructed. So just a quick review of this process. First, we used the slope and y-intercept to plot some ordered pairs. Then we determined whether our lines should be solid or dotted based on the inequality symbol. Then we have to pick a test point using the origin if we can. The only reason or time you can't use the origin as a test point is if your line that you constructed, our graph, actually goes through the origin. If the line itself goes through the origin, then we cannot use the origin as a test point. Any other time we can. We got a statement that was true when we plugged the origin in, so we shaded that region. So if I picked any ordered pair in this shaded region and plugged that into the inequality for x and y, we would get a statement that is true. Now to a second example, we want to graph the linear inequality. Y is greater than or equal to 2x. So first, plot some points, some coordinates on the coordinate plane. We have no y-intercept, or the y-intercept is 0. So we mark that point first. Now our slope is 2, so I go up 2/1. which is the same as down 2 to the left 1. So I plot some points. Now I have to determine whether this line I construct is going to be solid or dotted. I look at the inequality symbol. There is an equal to sign. So this time our line we construct through these points is going to be solid. So we construct that solid line through the points because we had the equal to in our inequality symbol. Now we have to pick a test point to determine which side of the line we're going to shade. This time we cannot use the origin because our line goes through the origin itself. So we can pick any other ordered pair to plug in those x and y values to see if our statement is true or not. Okay, so I'm going to choose to plug in the ordered pair 1, 0, simply because 1, 0, those are easy numbers to plug in for x and y. So now when I plug in the ordered pair 1, 0, I get 0 is greater than or equal to 2 times 1, 0 is greater than or equal to 2. That is a false statement. So if our statement is false for our test point we picked, that means we have to shade the region opposite of where that test point occurs. So 1, 0 occurs here. That means I shade the opposite region. So any point to the left and above this line will be a solution to this linear inequality. So the first thing we do is find our slope and y-intercept, plot some points, construct a line through those points, determine whether it's solid or dotted based on the inequality symbol, then pick a test point and shade the appropriate region. Any point, any ordered pair I pick in this shaded region, if I plug those x and y values in, would give us a true statement for this linear inequality.